Okay, in this problem, in this video, I'll do problem number 5 from the midterm exam review sheet. And problem 5 says, you want to write an access control list that allows all hosts from the subnet of a given host. Give the subnet ID and wildcard mask to be used for each of the following given host addresses. And so here, we're given host addresses with a subnet mask, and we're asked to write an ACL that allows all hosts from that subnet. And notice that we're not really given the subnet ID here. We're just given one of the IP addresses within the subnet. And so the very first step in this problem is very much like the last problem, where we were given an IP address in a subnet and asked to write down the subnet network ID. So that's the first thing we're going to have to do here. And then we'll have to put it in terms of an access control list. And so for part A, so let's make an ACL that permits the subnet. Okay, and for part A, it's 192.168.85.75/26. Okay, so the first thing to do is to figure out what the subnet ID from this is. And it's very much like the last one. In a /26, we have 64 networks. You can do that in your head. 32 minus 26 is 6. 2 to the 6th is 64. So we have 64 hosts or IP addresses in that subnet, and we count by 64. 192, 256. And we ask ourselves, which values is that last decimal value between? And it's between the 64 and the 128. So 75 is right in there. Therefore it's in the 64 network. So the network ID is 192.168.85.64. Okay, so that's the network ID, and this is a subnetwork of size 64, which means it's taking 6 bits to specify it. And so my mask has all ones in the second octet, all ones in the third octet, and 2 ones and 6 zeros in the last octet. Remember, a network mask has ones up through to the point where you get the host ID addresses. And so we have 6 bits at the end for the host ID address. But when you make an access control list, you invert the mask. Every 1 turns to a 0, every 0 turns to a 1. So the wildcard mask is zeros, 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 dot 00111111. So instead of having 6 zeros at the end of a bunch of 1s, we have 6 1s at the end of a bunch of zeros. And it turns out that when we have 6 1s at the end, that is just 1 short of the binary value 01000000, which is a 64. Okay, so this is a 63 at the end here. And so what we do is we write our wildcard mask in dotted decimal as 0.0.0.63. And the wildcard masks are nice because the last value is just 1 less than the number of addresses in that subnet. Therefore, we're going to write the ACL will have something like a name and a number and then a permit, and we're going to permit this network 192.168.85.64 with a wildcard mask 0.0.0.63. Okay. Okay? And so that's part A. Parts B, C, and D are very similar. And in fact, just like in problem 4 where I have the same IP address and different subnet sizes, I've got the same IP address here in this problem with different subnet sizes, /26, 27, 28, and 29. And the higher the slashed value, the smaller the network. And as I increment by 1, I cut the network in size in half. And so for part B here, I have the same IP address, .75/27, and in part B I'm going to have 32 IPs. I'm not showing all the work here, but I'd like to get through this video. I've got 32 IPs, and the 75 lies from 0 to 32 to 64 to 96. It lies between 64 and 96. Therefore, it's the 64 network. And it's the same answer, except we're going to have a /31 instead of a 32. Makes sense, I hope. 85.64.00031. Okay, for part C and D, it's very similar. For part C, it was 192.168. This is a private IP space. That's 75/28. A /28 has 2 to the 4th or 16 IPs in it. And now I'm going to count by 16. 0, 16, 32, 48, 64, 80, 96, ... Our 75 lies in between 64 and 80. Therefore, it's the 64 address again. And instead of being a .63 at the end for a subnet of size 64, or a .31 for a subnet of size 32, it's going to be a .15 for a subnet of size 16. So the ACL permit 192.168.85.64 0.0.0.15. Okay, for part D, it's a /29, which has 8 IPs. And if I count by 8, 24, 32, 40, 48, 54, 56, 64, 72, 80, and my 75 is in between 72 and 80. Therefore, this is the .72 address, and the ACL, yeah, you can still see it there, is permit 192.168.85.72 0.0.0.7 because it's one less than 8. And if you want, you can go through all the details on calculating the .7, but basically it has 3 1s at the end. And that is a binary 7. And that comes from the fact that we've got 24 zeros plus 5 zeros gives us 29 zeros, and then 3 1s at the end gives us the .7. So that's how you do problem 5. Hope that helps.